Hey everybody, it's Tom Cherims with the FujiNet project, and I wanted to catch you all up to date on some wonderful work that Michael Sternberg has been doing, taking the original FujiNet network operating system code that I did as a proof of concept roughly 2 years ago, and bringing it forward and making it useful, and to kind of show that it's actually starting to work really well, and the potential of what it can actually do, and why you would want to do such a thing. If you want, you can actually get a copy of the FujiNet NOS. It's part of the FujiNet nHandler repository that's in FujiNet Wi-Fi here. You can grab this down, you can pull it in, you can go into the NOS folder, and there is a build of it here, but you can take it and you can build it yourself. The whole thing is implemented as pure assembler, compilable with the MAD assembler. And you can see exactly what you need in order to implement something like this. Now, what is this exactly? Well, think about when you boot a particular disk operating system. Let's say we want to take and just pick any old disk operating system and boot it into place here. Good old Atari DOS 2.0S, for example. We'll take and boot it. Wrong key. Somewhere, I have my function keys are working here, I swear. Click. Oh wait, I actually have to, that was my bad. Ignore that, I just had a brain fart. Now what has just happened here? Well, the disk operating system has been read from the disk into the memory of the Atari computer. And as part of that process, it has installed a device driver to handle the disk drive. Specifically, it has installed a device driver to implement a file system for that device driver for the disk drive. It's what happens, it's what allows you to take and put files on a disk, to retrieve them back, and to work with all of these, to work with the various files and things that you have on the disk. And once this is installed, it's accessible as a disk device. So it allows you to do things like take and to save something to the disk. And actually, I think I loaded it as read-only here, so don't mind that. But it gives you this disk device here so that you can read and you can write to it. Pardon me for a moment while I turn off the joystick arrow. Okay, so it gives you the ability to take and use this disk device here. Well, this disk device is implemented entirely on the Atari host system itself. It implements the file system and converts these high-level operations of reading and writing files into the disk sector calls that get sent to the disk drive. This actually takes up memory and it has limitations. So if someone writes a better file system, you have to load that file system in memory or that DOS into memory in order to use it. And it provides all the views, such as when you take and view the disk directory, looking at files, locking and unlocking files, etc. All of these things are implemented in that DOS.sys file that gets loaded here. And it's called DOS.sys here because the bootloader, the very first 3 sectors on this disk, have a program that looks for this file and loads it into memory. And then that patches in the D device. But does it have to be this way? No, it really doesn't. You can load a totally different handler into memory that provides, basically lets the FujiNet do all of the work. And what you get is suddenly you can, and if you pair that, say if you take the N handler here, if you load the N handler into memory, you get the N device. You do it at boot, you get the N device at boot. Now, I'm not loading a D device in here at all. We aren't. There's no native disk file system, just the N device. And in fact, it takes it a step further with this latest build in that it takes and also vectors the N device as the D device. And because every single device in the central input and output system uses the same exact API, we can do this. Sort of, early universal device driver type stuff. So if we do this, pardon me, even with do not disturb, it still does. Okay. So take this a bit further. What happens now if I take and reload, and let's go pick up a copy of the NOS and load it. I built it and I have it here on my SD card. And I'm just loading it into place. And all we are doing here is using the built-in facilities in the Atari operating system ROM to load this disk operating system in one shot into memory, starting at hex location 700. That looks like this. Now we have right here, you'll notice that booted up very quickly. And that is literally because everything that this operating system needs is just, it's all making calls to the FujiNet. And if we type DOS, it actually drops us into a command prompt here. And we can do certain things. Right now, nothing is set up and nothing is pointing to anything. So if I were to try and do a directory, it would come back with an error 165 indicating that the URL is invalid. But we can change that. I will point out that we have, by default, up to 4 of these network device drivers that can all point to different places. D is ironically in the same place because we've aliased it. D1 and N1 are essentially the same thing, and so on. Let's move somewhere. We could start with my local TNFS file server. We do a directory and we suddenly see all of the files that are sitting on my TNFS file server. And since I'm doing Apple II development too, this is a bunch of Apple II images, but I have a copy of Netcat right here. I could just as easily take and load that. And because we're not limited to disk sector size loads, we're actually taking 512 byte chunks and loading them in as we get them. We could actually go faster. We could actually go better than this. But I mean, as you can see right here, we have Netcat and we can use it as expected. I can hit reset and we will find ourselves back at a basic prompt, or if you don't have basic inserted, it will simply take and simply drop you into the NOS prompt. So the N handler is still loaded and it's still taking care of requests for us. We can see where we are. We can see that we're currently sitting on the TNFS file server here due to the directory, and we can see that we can load files. But there are a host of other commands as well that every FujiNet file system adapter can implement, such as making directories and going into them. We can go back, and we can, of course, remove them. And so on. But we're not just limited. We basically can use any file system adapter that FujiNet has, such as FTP. Give me a moment here. The caps lock in Altera in Linux is a little bit funky. Okay. Yep, there we go. So now I can traverse up. We can go through the individual collections. Say we want to go to home CD. I have to use the quotes for this. We'll go even further. We'll go into home 2. We can go even further. You can put the slash or you can not. The NOS will automatically do the right thing. Oop. Sorry about that. I now realize what I did wrong. Give me just a moment. This is why you shouldn't guess too far up into a directory tree. Because you might type it wrong. And you need the space because otherwise it will not treat this as a single string. Atari, yeah, okay. And we just keep going up. And I'm going to go up into an Antic archive here. We can, of course, we have the ability to do wildcard, so we can filter for things just fine. No problem. And we have the entire Antic software collection here for a few years at least. We'll go into 88. And here we're knee deep into a file archive of a mixture of basic programs, executables, action source code, Max65 code, and it's a good little test case for showing that all this is extremely transparent. For example, if we do a directory, we can look for all the basic files. And even in this directory, there are a lot of them because this is for the entire year of 1988. Oh, sunset looks nice. Let's go to the cartridge. Now, because we've set this directory prefix, I can either put N or D in this case. It's interchangeable. So we'll take and hit the warm reset. Or I could just as easily goes to the same place. you see it's extremely transparent, or even load a binary file. Frog looks nice. And you can see it's just doing the right thing no matter what. No matter which file, no matter which protocol adapter I'm using, it's making the necessary calls to take and make this thing look like something that the Atari can understand. Now, what does this ultimately mean? Well, think about it a little more and extrapolate out. If you have the ability to handle multiple protocols, multiple protocol types, such as FTP, HTTP for like WebDave, HTTPS, so that you can talk to a web server directly, or SMB, or NFS, TNFS, all these different file system protocols that we currently support. You have access to all these network resources directly on a file-by-file basis, and you can use them in your Atari programs as is. They work. And because we've gone through the trouble of not only making it possible to set network prefixes so that it looked like a disk drive, but also that it looks like, so that it matches the D drive here. Any programs that expect to only use the D: device will still work. D1, D2, D3, D4, all that. But let's take it a step further. If you were, for example, to implement a protocol adapter for a particular disk image type, let's say a particular file system that's stored on a disk image. For example, a file system driver type for Atari DOS 2.0 images, a file system driver for DOS disk images, a file system driver for CPM disk formatted images, a file system driver for FAT16, FAT32 file systems. Whatever file system you wanted to have access to that you had on a disk image somewhere. The FujiNet could take care of all of the details of implementing that without any changes whatsoever to the NOS. Just works. The FujiNet here has the commands that just pass themselves all the way down to the drivers. So if the file system supports directories, you have it. If the file system has long file names, you have it. It doesn't matter. And that opens up a great deal of flexibility and leverages the FujiNet to have access to things that, again, just like the end device gives you access to modern web endpoints and modern security, etc. The having these different net protocol adapters for disk images as well would give you access to files inside those disk images very easily. Disk images, archive files like ARC, zip, whatever, 7Z, XZ, etc. Doesn't matter. Or to think even further, protocol adapters for cloud storage services such as Google Drive, OneDrive, Dropbox, etc. all suddenly become directly accessible from this Atari NOS right here. I hope you guys have enjoyed this little status update showing that this is almost ready. You can go ahead and download and compile it yourself, but Michael has done an absolutely wonderful job, and he's actively working on this project to try and take and button it up. Just as a very welcome, what I consider to be a welcome alternative to running a full-blown DOS into memory. And the total footprint of this entire DOS, of this entire NOS right now, is just under 3K. We can probably do better, But, that's really good. You have a really low memload here without sacrificing without sacrificing a lot of functionality, and in fact, opening the door to a whole bunch of new functionality. So, hope you guys have enjoyed this, and until next time, guys, have fun.